Hello everyone, welcome to this module where we are going to discuss about messaging services on AWS. So what are the topics that we are going to cover over here? We are going to understand about Simple Queue Service and Simple Notification Service of AWS. So in Simple Queue Service, as the name suggests, it is a queuing service. It helps us to buffer the messages or the requests that are coming in. So we would first understand that what is SQS. We'll be understanding about benefits of SQS. We'll be understanding two different types of queues available. One is called as standard queue and another one is called as first in, first out queue. And lastly, we would understand about important configurations of SQS. So what is SQS? It is a fully managed service which is used for queuing. So it allows you to decouple and scale your distributed systems by providing reliable, scalable, and flexible queuing service. Now, what do you mean by decoupling? So decoupling means, let's suppose that our web tier is there. The web tier is it's accepting so many requests. Okay, here there are EC2 instances and it is accepting a lot of incoming requests. The processing tier takes some time for processing those requests. So if directly all the EC2 instances from here on the web tier, they send the request into the back application tier, then what will happen? It will overwhelm the application tier. So that's why we want something in between, which is our queuing service. And that queuing service is SQS. It will help you put all the messages to the queuing service. Okay, the messages would be put here and the application tier would be reading the messages from the queue. So this is not the push mechanism, like queuing service will not push the messages out to application tier. Instead, application tier needs to pull the messages out. So you can get a good level of throughput over here without losing any kind of messages. So this extra additional layer into our tiers is called as decoupling our distributed systems. So this is what I told you previously. Okay. So what will happen? The application load balancer would be putting out the requests to all the EC2 instances. We would be having the SQS over here. What this queue will do? This queue will be taking up or accept all the messages, and these messages then can be read by the application tier. This is our web tier. Right? So this is what will happen into our queue. So now let us understand the two different types. Okay, first of all, we'll understand the benefits of queue and then we will be understanding about different types of queues available. So the benefits of queue is basically security, first of all. So security, why it is secure? Because you can control who can send the messages to and receive the messages from an SQS queue. You can choose to transmit sensitive data by protecting the contents of messages in the queue by using default SQS server-side encryption or by using custom server-side encryption where keys are managed into KMS. So two things why it is being secure, because we can use IAM policies to define that who would be sending the messages to queue and who can receive the messages from queue. And other security feature is encryption. Next is durability. So for the safety of your messages, SQS stored them on multiple servers. So there are two types of queues that we'll be discussing soon, but standard queue will support at least once message delivery and FIFO queue will support exactly once message delivery, providing the high throughput. So durability is being maintained by storing the messages into multiple servers. Next is availability. So SQS uses redundant infrastructure to provide high concurrent access to messages and high availability for producing and consuming the message. So availability is maintained by redundant infrastructure. Then we have scalability. SQS can process each buffered request independently, scaling transparently to handle any load increase or spikes without any provisioning instructions. Why we don't need to provision any instruction is because this is a serverless service, right? So you don't need to provision anything over here. Next is reliability. So SQS logs your messages during processing. So let us say that we have multiple consumers consuming the messages from the SQS. So if this consumer A has taken this message, okay, if it is consumed by A, then it will be logged. No other consumers can actually see this message then. Okay. So it will lock your message during processing so that multiple producers can send and multiple consumers can receive the message at the same time. But the processing would be done once, so this will increase the reliability. Then we have customization. So your queues don't have to be exactly alike. For example, you can set a default delay on a queue. You can store the contents of messages larger than 256 KB using simple storage service, that is S3 or DynamoDB, with SQS only holding the pointer to the S3 object. Right. So what happens over here is there is one limitation of SQS that the message size can be just of 256 KB. SQS can handle one message of 256 KB. It should not exceed that. So if you want something to be processed which is, higher than 256 KB, then what to do? Then you have to actually put that message into S3. Okay, any message which is greater than 256 KB, I will be putting that into S3. And from this S3, what I will be doing? I will be passing the URI or URL or endpoint of the S3 object into the SQS. And when we write the processing logic, we would be writing the processing logic in a manner that this message would be, the processing logic would in a way that the message is just a pointer. Okay, we would understand that message is just a pointer to S3. The actual message would be then fetched from S3 and would be processed. So these are all the benefits of our SQS. Now if we see about the types of SQS, then there are two types of SQS queue. The first type of SQS queue is called as standard queue. So by default, all the queues are standard queues. They can support unlimited number of API calls per second and per API action. So here it will basically nearly support unlimited API calls. You can just make so many API calls at the same time on that queue. But the thing is, it will support at least once message delivery. What I mean by that is, there may be chances that you might get duplicated message because it is at least once delivery, right? So sometimes it may happen that due to high traffic, it will be delivering the messages twice. Generally, the messages would be in ordered form. If I am sending, let's say that I sent the orders A, B, and C. Okay, C is sent first, B is sent next, and A is sent third. Suppose that is the case. So in the queue also, C will come first, B will come next, and A will come last. But sometimes it may happen that the order is not maintained. Okay, it may happen that B came first, then C, and then A. This can be the case. It provides us with the best effort ordering. Okay, but the thing is, it is always not the case. So if you think that ordering is strictly required for your use case or your workload, then you have to necessarily go with FIFO queues, that is FIFO, first in, first out. So first in, first out queues have all the capabilities of the standard queues, but they are designed to have enhanced messaging between application when the order of operation and event is critical or duplicates cannot be tolerated. Because with FIFO queue, it is guaranteed to get at most once delivered. So your message will be delivered only once, and that too in ordered form. It will be always in order. There won't be case of out of order messages. Because it is maintaining the order and because it is maintaining that no duplication should be allowed, that's why what happens here in the FIFO queue is, it is not, it will not handle unlimited number of API calls. FIFO queue will support 3000 API calls per second. So where you might want to use the FIFO queues, you want to use into the e-commerce order management where order is critical. Okay, the order is critical. You can be using it into online ticketing system where tickets are distributed on a first come first serve basis. So these are few of the example situations where you would like to use the FIFO queue. The next topic here is about the configuration of our queues. So while creating the queue, we have all these configurations that we have to give. So what are these configurations? The first is visibility timeout. This means that the length of time that a message received from a queue by one consumer won't be visible to other consumer. Okay, what it means by that is, as I told you, that multiple producers and consumer might be putting the messages on queue. So if I have my EC2 instance, okay, then what happens over here is it will take up the message. There are two EC2 instances, so two consumers are there. If one of the EC2 is taking up the message, then whatever the timeout is being set, let's say 20 seconds, then for 20 seconds, the other consumer won't be able to see this particular message. Right? So that is called as visibility timeout. The next is message retention period. So generally visibility timeout is set to the time duration which one consumer requires to process the message. The next is message retention period. It is the amount of time that Amazon SQS retains messages that remain in the queue. By default, it will retain the messages for 4 days, but it can go up to 14 days duration. Next is delivery delay. So delivery delay is the amount of time that SQS will delay before delivering the message that is added to queue. So if you want to send the message to the queue after some delay, just to not overwhelm your consumers, then you can do so. Then there is maximum message size. So maximum message size that can be having for SQS is 256 KB. But you can increase or you can decrease this as well. You cannot increase this. Basically, this is the highest limit. But if you think that your message is of smaller size, then you can reduce this size. Then there is receive message wait time. So this is the maximum amount of time that SQS wait for message to become unavailable after the queue gets a receive request. So over here we talk about the long polling and the short polling. What is long polling? Let's say that I am having a queue. I am having this consumer. So this consumer would be requesting for receiving the messages. It will send the request to receive the message, okay? So what happens over here is, it will send the request, it will wait till the time the messages are available in the queue. Or the timeout happens, okay? If the timeout happens, then the empty response will go if no message is being received. Or else it will wait till the time the message is being received and it will take the message back. Short polling on other hand is, I have my consumer, I have the queue over here. So short polling means it will again and again hit the queue and will say that whether the message is available, is there any message, is there any message, is there any message. So this is what the short polling is all about. So what will happen in short polling is, we will receive the message as soon as it arrives in the queue, but the number of API calls increases over here, therefore the charge also increases. So that is receive message wait time. If we set this receive message wait time as 0, then it means we want to do short polling. If we have this receive message wait time anything greater than 0, then it will become long polling. Then we have enable content-based deduplication. So SQS can automatically create deduplication IDs based on the body of messages. So if there are duplicated body, then it will make the deduplication IDs. Then we have enable high throughput FIFO. It is used to enable high throughput for messages in the queue. Choosing this option changes the related option, deduplication scope, and the FIFO throughput limit to the required settings for enabling high throughput for FIFO queues. Lastly, we have the redrive policy. It defines which source queue can use this queue as dead letter queue. Okay, if we want to use dead letter queue, now what is dead letter queue? If certain message is being processed, multiple times, and even though it is not being processed, we are getting the error, then that message would be put into dead letter queue. Some manual intervention or some other logic would be there, which would be checking that why that message is not getting processed. And redrive allow policy defines that which source queue can use this queue as a dead letter queue. Right? So dead letter queue is just like any other queue, but if it is used for handling such non-processable requests, then it is called as dead letter. So these are all the configurations of our SQS.